Let's take a moment and thank our sponsor, Text Control. There's always something new from Text Control. As a developer, do you need to integrate PDF generation, document editing, or electronic signatures into your ASP.NET Core or Angular applications? Or maybe you want to learn more about the differences between electronic and digital signatures. Text Control is offering a free consulting service to educate you about digital document processing and how Text Control products can help you add these features to your applications. You just go to textcontrol.com/contact and you can request your free personal consultation. How cool is that? Textcontrol.com/contact and you can request a free personal consultation from our friends at Text Control. Hi, I'm Scott Hanselman. This is another episode of Hansel Minutes. Today I'm chatting with Damian Edwards. Damian, I am chatting with you on my brand new computer that I built myself with my own hands, but with a lot of your help. Thank you very, very much for enabling me to have a new computer. I appreciate it.
It was a lot of fun. I was I enjoyed that 4 and a bit hours that we spent where I was basically your lifeline, guiding you on what to do and talking you and the audience through. We had a few people watching too, so that was fun.
Yeah, it was very much a keep talking and nobody explodes kind of bomb defusal moment. If folks can check it out on my YouTube at YouTube/Hanselman. We did 4 hours. Now, we could have probably done it in 90 minutes, but we did a really kind of exquisite, leisurely discussion about building stuff. And I got to tell you, I have forgotten how much I've forgotten. Like, I don't know anything about computers anymore. I used to be a PC builder. What happened? Why don't I know anything anymore?
It's funny you say that. It's like, I think if someone asked you to, with a notepad and pen, draw the lines and boxes that constitute the inside of a normal desktop computer, you'd have no problem at all. Obviously, a lot of people who have done anything with computers in the last couple of decades would have no problem. Where it gets more interesting is when you go into one of those boxes or the lines between those boxes, you say, okay, what standard or how many bits or what's the connector type or et cetera, et cetera, et cetera. What speed does that box run at and what does that mean and how does that impact the overall system design? Which two boxes might have some compatibility issues that you need to be aware of? That's the stuff that changes every year. It's an ever-moving target. So the basic, there's a motherboard and there's a power supply and they go in a case and you might plug some things into the motherboard. And then there's a CPU, which is a Intel, AMD, blah, 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 whatever it might be for this year. And there's some RAM and there's probably some storage in there. Like that stuff hasn't changed in 40 years, but the individual components that we're talking about there and how they connect together, like I said, it just doesn't stop changing. Every year there's something new going on. So
yeah, I think the last time I cared, I was plugging in SATA drives and a DDR3 memory and some kind of an LGA something slot.
Yep.
And I felt very competent and comfortable. And I think the big issue for me a number of years ago was water cooling because we had moved from tanks to kind of self-contained water-cooled setups. And then I blinked and I built a new machine and you put together a PC part picker list, and we'll link to Damian's PC part pickers list in the show notes. And suddenly things were more complicated. And not to mention, the standoffs and the screws and all the little things where I could have gotten myself in trouble.
Right.
Where you caught it. You're like, oh, don't hold that over the motherboard. Chances are you'll drop that screw. And now you've bricked a motherboard.
Right. And some of that stuff, obviously, you learn the hard way through experience. So having either done it or watched someone else do it and go, oh, I need to make sure I don't do that, is one way you learn those things. But the other way is and you say it was more complicated, but in some ways it's actually, as someone who first built PC clones, as we called them back then, in the early 90s, and then thinking, looking all the way through the last, 3 decades, that is. 3 decades!
All right, look, you are old, Damian.
Decades. As you said, a lot of it is very similar. There's a case and you put these standoffs, which are like little brass nut bolt things that the motherboard goes on. And we used to cable tie because there were lots of cables. So you'd like neaten the cables up inside to make sure there was a nice place to work when you had to fix your PC and stuff like that. And then fast forward to now, a basic desktop computer build will now typically only have power cables. Like you don't have any other type of cable. There's no data cable. There's even less cables coming from the front of the case where the little LEDs are blinking to the motherboard. There used to be a lot more of those. You'd have a hard drive LED, and then like each hard drive might have its own LED. Like I remember building servers like that. But now a lot of it's just in the motherboard, including like your graphics might be in your CPU. So there isn't even like a daughter board for your graphics. So
yeah, when I booted this up for the first time without the externalized GPU, it was perfectly reasonable. I could run 2 or 3 monitors just fine on it. I mean, Intel integrated graphics isn't anything to necessarily, phone home about, but it was perfectly competent for what it was, and I was impressed. You're absolutely right. The back panel has everything that you need.
Yeah, there was a time gone past, right, when you would, if you wanted anything more than a couple of USB ports or a serial port or whatnot, you'd be installing cards in your motherboard, all the way back to sound cards before we even had integrated sound in the 90s. And now, as you just said, all that stuff's just on the motherboard. It's kind of table stakes. It's just kind of like, yeah, you just expect there's going to be 7.1 audio. There's going to be 8 USB ports. There's going to be a DVI display port, an HDMI port. And it's only, for specialist kind of things that you need to add an extra card these days, with the big exception being graphics cards. For if you're doing any type of gaming or any type of video work, you almost always are going to want an external graphics card.
And the motherboard that I bought ended up looking like, if you look at it, it basically has like one slot for a video card and maybe another slot for some obscure thing you might want. While 5 years ago, I had 3 or 4 slots and ended up putting in a USB-C extra board because I needed that. Yeah.
Right. Yeah. So like you wanted extra USB controllers to avoid bus saturation, because you might be running more than one camera and all those type of things, and they all, because of the nature of a USB, this S stands for serial, and they're all sharing the same bus. And so it might say, oh, it's 5 megabits per second or 10 megabits. And that's like, yeah, that's shared across every USB device that you have plugged in to that controller. So you can still have scenarios when you want to plug extra stuff in. But I think you're right. It has become more complicated and less complicated depending on which way you look at it. It's kind of one of those things as if you've just not had your finger on the pulse of what's happening year to year, and you page back in 5 years after your last build, it can be a little overwhelming because it's like, wait, everything I knew is different. There's all these new problems I have to think about that I didn't have to think about last time.
Mm-hmm. So we're a couple minutes into our podcast here. Maybe we've already gone off into the weeds. Let's try to make it a little bit more accessible for our friends that may not have built their own PC before. Do you think it is important, or why is it important for someone to build a PC at least once to have that experience?
Yeah, I mean, that's an interesting question because like the word important can carry a lot of weight. I think it's interesting to build your own PC once. And I think if you took a step back, you could say, well, you'll get some, it'll be an interesting experience for a number of reasons. You'll get some, you may have to work through some issues, which could be, character building and all that type of stuff. Problem solving is probably good practice in what you always do. But I think what you're getting at is more the fundamental understanding of what's going on inside the box. And it's like, that gives you a new appreciation for what's happening behind your daily driver, or if you're a software engineer, what's driving your software. And then when it comes time to when you have a problem, you might be able to solve that problem yourself. And in that way, I guess it's like any other DIY. Like if you appreciate, I changed a washer in a faucet in my home, or I did some plastering or whatever to fix a hole in the wall, whatever. Those things can be daunting if you've never done them before, but gosh, we live in an age now where it's more accessible than it's ever been to learn how to do something like that by watching a video on the internet from, a dozen willing people who are going to share their knowledge with you in a 5-minute clip. And I think back again to like my family when I was young, they didn't have that. They would just get it from their parents, or they would get it from a friend, or you'd go to the hardware store and you'd talk to an expert. And now you can just watch YouTube while you're sitting down and learn how to do something.
I've actually got a book behind me on the shelf that's a big, thick, it's called like the Homeowner's Guide that my dad gave me when I bought my first house. And it's just like, here's the giant book from, I don't know, Reader's Digest or whatever.
Yep, I remember getting those books as well when we moved out into our own home. I think we even bought one ourselves, like the DIY Bible type of things. And it's like, yeah, you may need to fix your sash window, like cut it open, get the rope out, and like all those type of things are the old type of stuff that we had. But I think ultimately it's that kind of element. It's like if you're willing to kind of have a go at it and it interests you, there is something to get out of it. Now, I'd like doing it like just recreationally. I just enjoy it. I started out in the industry building PCs in a small PC shop in the early 90s. And I kind of, when the pandemic hit, I kind of found myself going, well, I kind of need something to do at home. And I figured it was a good time to rebuild one of my PCs. And that led to building like a dozen PCs over the next 18 months or so for other people. So
yeah, and I'm on your PC part picker webpage, and you've got saved parts lists for all kinds of folks. Some of the names I recognize, some of the names I don't. So it's just like Seths and Pauls and Jeffs and the Hansel rig and Brennan's and Fitz and all these folks that you've built these machines for.
Right.
So you made me a list. So I said, I'm ready. I want a list. You made me a list. When you make a list like this, is there any chance you might put in incompatible things, or does PC Part Picker prevent you from saying this won't fit in that slot? How much trouble can you get into if you build your own PC?
Yeah, that's a really good point. One of the things about today is the market for PC parts is just, I guess, more broad. There's just more variation and more selection. And what comes with that, obviously, is while there are standards, there are many ATX cases, but they're all different sizes. And so while the ATX motherboards are all the same two-dimensional dimensions, they can have a different Z height because they have like heat sinks and all types of wonderful differentiating things on top of them. And then the cases have different lengths. And so there's like, mini ITX and mid ATX and then full ATX and then extra large, and those aren't standards in terms of the case size. That's just things that the case manufacturers say. So you kind of get to a point where you do need to understand a little bit about, well, I'm going to put this specific graphics card in it and its dimensions are XYZ, and I need that to fit in this case with enough clearance to run a cable behind it or put a cooling pipe or whatever it might be for your particular build. So the PC Part Picker website is particularly good because it's basically a big community-driven database of all the parts and then like links to all the vendors that you can get them from and their current pricing plus their pricing history. But really importantly, it'll do these compatibility checks when you put a list together, and it'll say, hey, not only physical dimensions, or it'll tell you if it doesn't know the physical dimensions, and so you might have an issue. But things like power draw. It's like, oh, your power supply you've put in here as a 750 watt, but the parts you put in look like they might peak at 850 watts. So you might have a problem there. You might want to up your power supply rating a little bit. So that helps, obviously, and that takes a little bit of the guesswork out of it. The other thing is that you can look at other people's completed builds, and you can just use those as a template and say, well, if it's been successful for them, maybe I'll just copy their build.
Yeah, we got a 360 millimeter 3-fan CPU cooler, and then we had an issue with it because it arrived broken and damaged, and I was not able to source a replacement in time. So I said, well, why don't we just use this 480 millimeter one? And you said, I don't think that'll fit. And we talked about that for a little bit, and then later I went and researched it, and it turns out it will fit, but it also won't fit because it depends on what else is happening in the case. So it became quite the truth table, this almost flow chart of like, yes, you can fit a 480 up here, but in doing that, you now have excluded yourself from fans in the front that look like this because there'll be a lip, And it was like, wow, it wasn't just a this fits, this doesn't fits. It becomes an if then, if then, if then. And it was quite nested and complicated for me to understand.
Yeah, absolutely. Yeah, so like I think the next size up is 360 is what you had, and it's 360 because it's three 120 fans, and so three of those together gives you 360. And then I think the next size is actually 420, and that's three 140 fans, which are the bigger fans that you typically see on cases. And as you said, what happens is while if you had nothing else in the case, yes, you could put the cooler there and it would screw in. The problem is you now can't put your motherboard in, or you can't put a case fan on the front, or you may not be able to fit your hard drive in, or whatever it might be. And so, the good case manufacturers, and this is where a lot of the, like in lots of markets, the difference of $30 on a particular item can be the difference between a case manufacturer with lots of good documentation about what works and a case manufacturer that comes with a single leaflet that says, yeah, this case has these features, and then that's it.
That's a great point. So people can take a look at the YouTube, and we bought an MSI motherboard, which, and people were asking in the comments about why we did that. We did a split screen where you could see me with the motherboard on my bench, on my desk, and on the left, we had animated GIFs step by step showing exactly how to seat things into the motherboard.
Yep.
I found that was really impressive. It wasn't just a pamphlet. It wasn't just a PDF. It was a complete interactive build your own system. And it really was like, be careful. It was like IKEA. Don't do it like this, big red X. Do it like this, big green check.
Yeah. Yeah. And it was funny because it was like you can run into the same problems as IKEA. Like they go into all this effort to give you step-by-step instructions, but the nature of how we put things together is if you you may just skip ahead. Oh, I recognize this picture. This is where I'm up to now. And you skip this really salient circled piece. It's like, no, you have to have the screw in this hole, not this hole, before you go to this next step. And I've, like many people, I think, who put IKEA furniture together have been caught by that, where you're 4 steps ahead and you go, why doesn't this fit? And you leaf back and go, oh, I was supposed to do it this way. So that stuff can still happen. But yeah, having that instruction there because the manufacturer went to the extra trouble.
So I gave my other PC to my son, and we had some issues with the fan. One of the 3 case fans in the front started going, making weird noises. So I went and I bought I can't remember the exact brand, a Corsair LED, 120 millimeter fan, and it looked this exact same. And I plugged it in. Well, apparently it's not the same because it doesn't have custom. It's a white LED fan, so it only has.
Oh, it's
not addressable RGB. So I plugged it in. If you look at it, it's identical, but it's missing a cable.
Yep.
So now we have all of these wonderful, colorful fans, and then this one fan that's just chilling in like white. And weird stuff started happening. Initially, none of the other fans turned on because you have to have them plugged in a certain order, and there's a fan controller. So then I discovered that fan controllers are now a thing, and they might come with your case, and they might be on the motherboard, or they might be entirely separate, and you've purchased a separate fan controller. When did RGB lights and colorful things become a thing?
That's probably, I must admit, one of the things that surprised me the most when I got back into it was the enthusiast level sort of products where people were doing custom water, cooling with pipes and then lights and LED strips, not just fans, but like the motherboard has built-in LEDs, obviously the video cards. There's this whole gamer aesthetic that has kind of leaked down a bit from the niche that it used to be into the mainstream to an extent. And I think a lot of that has happened perhaps with the advent of Twitch and streaming, like this whole online streaming. I've got my headset on, my gamer chair, and my good lights, and then my water cooled PC just in shot that you can see. It looks beautiful. Like that's a fairly recent phenomenon, and so I think you've seen a lot of the PC component manufacturers have gone, oh well, there's an opportunity to differentiate, or it's become table stakes. It's like, well, if you don't have RGB and it's not an RGB line of products with a brand name that's associated with it, like Mystic Light, or I think Corsair's like IQ, and then Razer has theirs, and like everyone has their own little RGB subsystem, and then you can integrate them together. It's kind of like, wow, I didn't have to worry about this 10 years ago when I built a machine, but now I can't. It's very hard to buy something that doesn't have RGB.
Someone on Twitter said, well, can't I just get one that's not clear? I don't need to see the inside of my PC. But I'm like, well, I kind of like seeing the inside. It could be interesting stuff happening in there.
That's right. And the truth is you can get cases that don't have, that's so funny actually. It's like glass panels on PC cases. Like when did that start? Like that was not a thing 20 years ago.
They were not fun looking. They were just like amber.
They were not fun looking. They were silver and beige with like the odd colored cables that never matched. It was never aesthetic. And now, sub $1,000 PC build, you can get a beautiful all matte black aesthetic with, just the kind of that electronic-y vibe, or you can go full RGB if you want to.
Hey friends, I want to take a second and thank our sponsor, Zencastr. You know that I've been doing Hansel Minutes now for over 850 episodes. And in the old days, I would have a guest manually install Audacity and they would FTP their WAV file to me. And it was a mess. But for the last several hundred episodes, I've been using Zencastr. It's an all-in-one podcast production suite. It runs entirely in the browser. It's got now video, HD video. It's got built-in voice chat. I do footnotes. I've got a soundboard for live editing. It's absolutely brilliant. And it also uploads to my cloud. The guest shows up, they go to a URL, they record, and the next thing you know, in my Dropbox or my cloud storage, a file appears. It's absolutely brilliant, and they've even now got automatic transcripts. And they are now sponsoring the show, and you can go to Zencastr, zencastr.com/pricing, and use my code HanselMinutes. And you'll get 30% off your first 3 months of Zencastr Professional. I want you to have the same easy experience that I do for all my podcasting and content needs. It's time to share your story with Zencastr. So let's get into a little bit more controversy here, though. So I built this thing, and a lot of people were excited, and I tweeted about it, and people are looking at your parts picker list. But a number of people are saying one of two things. One,
Mm.
PCs are dead. You should have just got a small ARM thing like a Mac Mini or one of the new Project Volterra little ARM devices, because it's a disk,
Mhm.
like it's a small box, it's tiny, it's silent. And then other people said, why power hungry Intel? Intel seems to have gotten squarely the reputation of being power hungry versus things like AMD. So was it a mistake for me to build this machine?
Wow. Well, that's like a lot of things. I think a very personal choice, but lots of people have opinions about it. So let's talk about why they might have some of those opinions. On the first point, with regards to big, powerful PCs are dead, you just should buy some small ARM device. In my shot here, no one else can see it, but like you can see, I have a Mac Mini under my monitor behind me here, so I have one of those, and I use those for certain things. And I think it's certainly true that for a large class of users now, that's all they're ever going to need. And what I've also noticed, like my wife uses a laptop I bought her 6 years ago, and it's still wonderful. Like it's an HP Spectre X360 laptop. It's got like a 7th gen actually Intel in it, so it's quite old now. But it runs wonderfully, and it's kind of amazing how for everyday use, folks who spend most of their time in a browser and maybe the occasional device plugged in or whatever it might be, they can, if there's like a price point that if you buy at that price point, it'll last you years and years and years and years and years now. But for other folks like software engineers, people who do video editing, gamers, some sort of that enthusiast level, there's almost an attitude of I can never have enough power because I do certain things during my workday every day where my CPU is flat out and it just takes as long as it takes for that particular operation. Or I run lots and lots and lots of programs all the time. I generally have 3 browser instances with lots of tabs in them. I have a terminal window, 2 Outlook windows, a Teams window, a music player, a messaging app, whatever else running. But databases are running, obviously, because I'm coding and stuff as well. And all of those things, even when idle, will take some cycles. And I want the machine to react very quickly when I want those things to work. And so there are still cases for having powerful machines. If your job is to do stuff on a computer and you find yourself at all waiting for the computer to do stuff, it's slowing down your thought. In some cases, sometimes the idleness is nice and you can take a moment, but there's always going to be a case for people who need that power.
Well, thinking about like PCs are dead. There's that, and the ARM question. So you answered that, and then the next one is why a power hungry Intel? And I got the impression it was more than just kind of the religious argument of my religion is AMD or my religion is Intel. Now I pick Intel the same reason I pick Honda over Toyota. I started with it and I like it, but that's not a good reason.
Right. No, and it's certainly true that AMD really kind of re-entered the fray a few years ago with their 3000 and then 5000 series CPUs. In fact, the machine I have behind me, my gaming machine here, is a 5000 series AMD machine. And in that generation, AMD was ahead. Like they had much better power to performance, the value was there, and their peak performance was just much better.
Threadripper?
No, I didn't go Threadripper. So Threadripper is like another class above. That's kind of workstation class, which is you double the price of everything at least. But by virtue of that, you can then, instead of having a maximum of 128 gig of RAM, which is a lot, don't get me wrong, you can have half a terabyte of RAM type of thing or more in some of those rigs because you might be working on large CAD models or artificial intelligence stuff or like whatever it might be where you want the whole thing in memory. I don't need that. Like I just, for games and for Visual Studio and that type of stuff, 64 gig of RAM is typically fantastic. And then if I'm doing lots of Docker and VMs, then maybe I'll get use out of 128. And so there are classes. But going back to the AMD and Intel thing, what we've seen the last couple of generations is AMD moved ahead with their technology, their fabrication process. They use smaller like tracers and smaller transistors, similar to how the Apple and their ARM CPUs have gotten right down to like these single-digit nanometer stuff. I think now it's like 3 nanometer is the next generation, whereas Intel's fab is still, they've only really just cracked 10 nanometer, and some of their mainstream chips are still using their 14 nanometer technology, and that's where the efficiency stuff comes in. So the latest Intel 13th gen versus the latest AMD 7000 gen. Depending on the test, they kind of are blow for blow in terms of absolute performance. What I've seen, though, is there's a few teething problems with the AMD stuff at the moment for the kind of extreme cases. High memory, faster memory, high amounts of memory, I should say. Or if you compare power consumption, it's not always about how much power they draw at their peak load. It's also how much power do they draw during a whole day when your machine is clocking up and down, depending on what it's doing. And I've actually seen a number of tests where the Intel actually comes out better because it clocks down better than the AMD. It's able to turn off more cores and get into like a real power sipping mode when you're not really doing much. And then it can ramp up again and draw 350 watts when you like hit every single core with a whole bunch of stuff. So I found it's not quite as straightforward as just looking at their peak power draw and then drawing a conclusion based on that. There's a lot of factors you have to consider.
Interesting. So it is power hungry if it needs power, but to your point about clocking down, I think about back to like Hondas and Priuses. My wife's Honda will turn off at the stoplight and just sit there because why should I be idling and wasting anything? So the engine just turns off completely.
Right. And then, and it's not to say, like I said, I have one machine that's AMD and I have one machine that's Intel. And I typically, moving forward, I just make that choice generation to generation based on who I'm building a PC for. Like you came with a preconceived kind of like, I want to go Intel because that's what I trust. Like, it's fine. Like I didn't feel I had to convince you. It wasn't like AMD was that far ahead this generation that I no, Scott, you really should go AMD. Here's why. It's like, nope, that makes total sense. I felt more confident we were going to get 128 gig of RAM to work on the Intel than I was on the AMD from what I've seen online. And it turned out that was the bit I was worried about the most. And it turned out to be not a worry at all. Like it just worked. And I'd like to think that we did the research. It's the research we did beforehand.
So let's talk about that a little bit. So I bought these stock parts. I put them together. I turned the thing on. It worked immediately. I booted into Windows, and I could have gone on with my life. But you had me go into the BIOS, right, the basic input-output system, and you had me go into XMP and make some changes immediately without even saying hello, without even, like, you're just like, before we do anything, go in here and apply these settings. Why did we do that, and why is that important?
Yeah, so one of the things that's happened is what we used to call overclocking. Like overclocking kind of used to be a risque word. It's like, oh, you're overclocking is when you're going outside the specs of the thing. And it was really left to kind of a niche enthusiast market. Now overclocking is like super mainstream. And in fact, it's been embraced by Intel, AMD, and the memory manufacturers. And so, Intel K-series CPUs, they come unlocked from the manufacturer. And AMD CPUs, I think nearly all of them are unlocked now. And they have software, they have utilities that you can install from Intel, from AMD, that let you overclock, like one button overclocking or all the way down to individually changing the voltage and the clock multipliers of every core and all that type of stuff. On the memory side of things, the XMP is a standard that was put together by Intel and the memory manufacturers and the motherboard manufacturers that basically said, hey, even though this Intel platform might only be officially rated up to this memory speed, we know that if you've got good motherboard, you've got a particularly good instance of a CPU, and you've got memory that has tightly manufactured and good tolerances, we know it can run faster. Like basically the spec is to some extent the lowest common denominator, and a lot of the time you can just run faster. And so rather than just leaving that up to a bunch of guesswork to consumers, they made a standard. And so the memory will say, I'm XMP certified. It'll have a bunch of metadata stored in the memory that you can go into the BIOS, say, choose XMP profile 1, that literally downloads those settings off the memory into the BIOS, and then it reboots and goes through a memory training routine to basically see if it's stable, to see if the system will boot when running at that speed. And that's where I thought we were going to run into issues, because running 128 gigs across 4 different memory sticks of DDR5 at this speed, like was over 5,000 megatransfers a second, is something I haven't seen a lot of coverage online. Actually, it's very little coverage. But we went to the motherboard manufacturer's website. We found the motherboard model where they started actually certifying 128 gig of RAM with DDR5, and they actually told you what memory sticks, like literally the model number of the memory sticks that they had used. And so we tried to match that. Like, okay, we'll buy that memory stick. We'll buy 4 of them. It's split across 2 kits, as you said. And then we kind of hoped. It's like, okay, cross our fingers. We'll see if it actually works. And it just worked. First time, I was flabbergasted. It actually had no problem.
Yeah, and we installed them in a specific way to make sure that we bin them together. And this XMP, this extreme memory profile, it's almost it's a standardization of the overclocking. So overclocking before was very much like, I'll pump it up a couple of volts. I'll put it up 1/10 of a volt, and I'll reboot. Oh, it didn't boot. Right. I'll back it off a little bit. I'll clear the BIOS. That whole inner loop of overclocking was a single button. And I went from, 4,000 to 5,200 in 10, 15 minutes. Right. And I was surprised by that memory moment that you were talking about, that memory training. It was doing nothing. And it was just blinking for 10 minutes, but then it woke up and it was like, yep, that sounds like that'll work out for you nicely.
Right. And that can be quite disconcerting because there's nothing on the screen. The machine is literally just turning on and off multiple times for many, many minutes. And it just looks like you're stuck in a boot loop. And then suddenly the BIOS comes back and the memory is what you set it at. It's like, oh, this is great. So that other type of overclocking still exists. Like there are still people who manually adjust their timings for the specific memory that they get. And they go through that cycle of trying to find the limits of what's stable. But I think what's happened is manufacturing has just gotten so much better that we now have this new tier. Like there's the standard tier, then there's this basically free, you're almost guaranteed you're going to get it tier just by clicking this one button, but you still have to opt in. And then there's still the extreme tier for the folks who really want to get the most out of their hardware.
So you're saying I could still go, like right now I'm at 5 gigahertz, 5.3. I could keep going, right? I could push this thing farther.
Potentially. And even if you don't get the memory speeds higher, you could get the timings down. So the latency associated with accessing the memory, you can continue to tweak. To be clear, I've never done it. It's something I watch people do on YouTube because it's kind of interesting, but I've never actually done it. I just don't have, I'm not chasing benchmarks or anything like that. So.
Well, and then speaking of benchmarks, you made a specific reference to a benchmark of Linus Tech Tips where they worked really, really, really hard to get a certain number. And with us working not hard, we got within spitting distance or over that number. Can you talk about that?
Yeah. So like there was a recent series on Linus Tech Tips where they were overclocking a 13900K, which is the same CPU that you have in your new machine, with an industrial chiller, which is designed to cool industrial like steel cutting lasers. And they got their hands on this because someone gave it to them, and it's worth like over 6 figures. This is ridiculous. Like imagine an air conditioner that's designed to cool water at some matter of gallons per second being pumped through it. And they hooked this up to the water cooler on their CPU. Like it was that kind of crazy. But the speeds that they were getting in the benchmark early on in that cycle were slower than what you got on yours on the very, very first run. And what that tells me is that their particular example of a 13900K, the silicon that they got, just wasn't as good out of the box as the one that you have gotten for whatever reason.
And that's luck of the draw, right? That's just
luck of the draw.
That binning.
Absolutely.
It's just basically I got a healthy, organically grown piece of silicon, and they didn't.
Yeah, absolutely. And so to be clear, when they then ramped it up and they tweaked a whole bunch of stuff, they started getting scores 10%, 20% higher than what you're getting on yours. But remember, they're using a 6-figure cooler, pumping gallons of water a second through the thing to cool it down. But I was just very, very happy to see that the particular example of the chip that you got with the cooler that we used, and we spent time mounting it well, and we talked through the mounting techniques and the amount of grease to use and all that type of stuff. That it went really well, and you got a really good score, and I was happy for that.
So right now I'm on that machine; it's working great. I do have a broken or a dented, aluminum cooler. The radiator is bad, but we're going to replace that. The folks at Arctic have great tech support. They called me; it's being shipped. It'll be here tomorrow.
Oh, so wonderful!
Now I have to go and unmount that piece, and then have an argument about what a pea-sized amount of
grease is
again. But that you don't think that's going to be a big bit of surgery?
No, and I think it's actually in some ways an extra educational opportunity, because one of the problems with CPU cooler mounting is that once you've made the decision about how much grease to put on, you don't get to see it once you've put it on. So you don't know how well it's spread out. You don't know if it's thicker in some places or thinner in some places because it's hidden. It's in the sandwich between the CPU and the copper plate. So you get to change it out. So what I would recommend is when you take it off, have a good look at the spread of the grease and go, okay, well, that pattern worked well. Or maybe, it looks a little bit sparse. Maybe I could just up the amount of grease I used a bit. Or maybe I'll try spreading it out manually before I put the new one on. And so that's something that you don't get to do if you just put it on and then go, it seems to work okay, I'll never look at it again. So I'd be really interested to see, actually, take a photo and send it to me when you take it off.
And then as we get towards the end of the conversation here, one of the things that I was really happy about with, this is now Ironheart 3 is the name of this computer. Ironheart 2, which we built, I want to say 5 years ago, is its longevity. I've been getting 5 to 7 years out of machines I was expecting to get 3 years out of. Is that because we just need less, or is it because they're just so modular and I've been able to add a little memory, add a little storage, I even added another chip.
Yeah, that's true. We did. I think it's a few things. I think one of them is what I said before, which is modern PCs, if you get to a certain price tier, they hit this sweet spot where they can just last longer because there's more latent power kind of effect. Like they're just so powerful now that if your daily tasks don't change so much, you'll get a lot more years out of them. And then the other part is what you said, is they're modular, and you upgraded your video card. I remember you got a 3000 series NVIDIA card when they came out. You put in a different SSD in. I think your original SSD died.
And I actually got a microcode update to the MSI motherboard and went from an 8th gen to a 10th gen Intel
CPU.
Because of the socket was the same.
Right. And so that was, that's right. And that was part of I think the Windows 11 update.
Mm-hmm.
You took that as well, I mean, maybe I should update my CPU, because you chose the Intel Core Extreme platform as it was back then, which had quite good longevity. Like the platform lasted a whole bunch of years.
Well, I was actually going to buy a whole new computer.
You were, that's right.
I could just pay a couple $100 and buy a new chip, and I got another 2 years out of it.
You did, absolutely. And so, the SSD, the video card, the CPU, you were able to update those. You'd put a USB card in it at one point as well to get more USB ports. But you didn't have to update the motherboard. You didn't have to update the power supply. You didn't have to update the case. Maybe a case fan dies once every now and then, that type of thing. Your water cooler, which was one of those integrated all-in-one units you talked about, that lasted the whole time, which was great to see as well. And so, you can, obviously the opposite can happen. If you can get unlucky and make a choice at the point in the cycle that turns out to be 2 years later, I'm kind of stuck. There's nowhere for me left to go. The standards have moved forward. And sometimes you can't pick those things. It kind of just happens. I know people who kind of wait for the right moment to buy the thing, and then they're waiting for 4 years and they never buy the thing. I think you can just kind of watch the trends over a couple of months, do a bit of reading, and you can kind of make a decision for yourself as to when the right time is.
I was going to end, but I realized there's one really important thing that we bumped into. The kind of like the quote unquote worst part, the nightmare scenario for the entire build wasn't hardware based. If you recall, we booted off of a USB. I downloaded a version of Windows 11 from the Microsoft site. I think we noticed that it was from September of 2022, so about 6 months old. And for the first time ever, and I have built probably 24 PCs, maybe 3. You've probably built 100. And I got into a situation where I had no network. I had no Wi-Fi. I had no wired network. Why did that happen? That was very surprising to me.
So that was a combination of a couple of things. One is you had a new motherboard with the latest Intel platform. It was Z790. And so that meant a new Intel chipset for the Ethernet controller and a new Intel chipset for the Wi-Fi controller. And neither of those, for whatever reason, network cards seem to be one of these devices where there isn't just like a standard driver that lasts for 20 years, like a lowest common denominator driver, like video cards. And so you always have to have kind of the latest network card driver to get it to work. And they weren't in that September build of Windows 11. And so it couldn't detect any network devices. And then on top of that, the Windows 11 out-of-box experience when you're setting it up these days defaults to you must have a network to continue. Like it won't let you get past a certain screen unless you have a network. And my understanding is that's done for a combination of reasons. One of them is security, so that it can connect to the internet. Like the first thing it does if you have a network card is connect and check for updates, downloads the updates before you've even gotten to the Windows desktop to ensure that you're secure. But it kind of left you dead in the water. And we had to do some online research to figure out how to get past that screen.
Yeah. So long story short, I got past that screen, but not without an unreasonable amount of Googling. And, it slowed me down for about 15, 20 minutes. And it probably would have taken my non-technical brother and it would have sent him back to the Geek Squad. But to your point, theoretically, when those chips, those Intel chipsets are built in, then it'll just work in another, 3 to 6 months from now. I'll just boot in and it wouldn't have been an issue at all. It would have been
Right. And it's also because you're building your own machine. If you buy a laptop from Best Buy or from Dell or anything, like they slipstream an install of Windows on with all the drivers for that machine. It's just something you don't have to worry about. But when you're building a machine from parts that you bought, you might have to think about drivers when you're setting up Windows.
Fantastic. Well, thanks so much, Damian. I really am enjoying my new machine and I appreciate you not only helping me out, but also, generously coming on both the podcast and the YouTube and sharing your knowledge.
Oh, absolutely. Thanks for having me, Scott.
We're going to share Damian's PCPartPicker.com. He's just username Damian Edwards. I'll have a link in the show notes. This has been another episode of Hanselman Minutes, and we'll see you again next week.